So I want to take this chance to quickly introduce myself. My name is Siamak Nakhaie. I've been doing research in material science and physics for about 10 years and currently work as a trainer for research data management at Fairmat. And Fairmat is a consortium of the National Research Data Infrastructure for condensed matter physics and material science in Germany. And yeah. And the contents that you're going to see now is basically based on a document that I, together with the team, tried to collect last year, and we're going to present you an abstract or a summarized version of that. So since we're entering the legal context, it's important to have this disclaimer here. The contents that you're going to see is basically for informational purposes only. They are not meant to be used as a substitute for legal consultation. And neither I and the other co-authors nor Fairmat assume any liability for any complications that might arise for the use of this information later. But let's start with the actual presentation. Why did I choose this title? As you know, the motto of the Love Data Week 2025 is whose data is it anyway? However, this is a really difficult question, and it's a topic of current ongoing discussion. That might be also interesting for researchers or even law experts. So for me to be able to answer this question easier, I narrowed down my target audience and removed the law experts, and we only have the researchers, and they're the people who generate data in the lab or at their PCs or for simulations and so on. They collect data, they analyze it, and once it comes to sharing, they want to share their results or data such that it has maximum visibility. And sometimes they might also want to use other people's data. And basically for this, they want to know if this is really legal or allowed to use those or not. That's why I try to deviate, but I try to change the title and deviate it from the focus, focusing on data ownership and put it on basically usage of the data and so on. So let's get back to the title. Whose data is it? If I read it like who owns the data, or in German, wem gehören die Daten, then I can go to the German civil code and find some clauses. Ownership applies only to things or Sachen, and the things are defined as physical objects. So basically, if the data are non-physical objects, they cannot have owners. There are also other clauses that support this. For instance, ownership transfer requires physical delivery, which means that if something is not physical, you cannot physically deliver it, and basically it doesn't have owners. However, there are clauses that distinguish between things and rights, with rights being the legal entitlements, not ownerships. So make it easy to answer this question. You can only own physical objects. Research data cannot be owned, but you can hold rights to research data if they qualify as intellectual property. So this is the easy version for us. If someone is more interested, they can refer to the scholarly articles from Max Planck Institute for Innovation and Competition. So we talked about holding the rights, but now let's see what are these rights. So again, I have this title here. However, this time, let's read it this way. Who holds the rights to the data? And then comes the next question. What are these rights? And in this presentation, we only focus on the copyright. So with this, I get to the actual contents of the presentation. I first talk about the intellectual property rights, tell what it is, different types of it, and then, as I said, we'll focus on the essentials of the copyright, and then exemptions, and the licenses, which will be followed by a summary. So what is intellectual property? Intellectual property is an intangible asset. It's not a physical thing, which results from creations of the human mind, like theses, dissertations, or graphs that you make for your poster, for instance, or manuscripts, images, and so on, paintings. And what is intellectual property rights? They are the rights which allow the creators or any other rights holders that can be not necessarily the creators, can be, for instance, a journal, to decide how, when, and where their creations are used or exploited. And exploited basically is similar to use, but with a wider meaning, like sharing is kind of exploiting the data, and so on. So let's have a quick look on different types of IPR. So the most famous one that we are aware of is the copyright. And we also have the database rights and sometimes industrial property rights like patents, utility models, and trademarks. Who holds the rights? If something is copyright protected, basically the authors or the artist or a scientist is the rights holder. If there is a database, the entity that invested substantially to make that database is the rights holder. And if this is patent or something else, basically the inventors or the companies are usually the rights holders. What rights do they have? On copyright, they have the rights, rights on what? So for copyright, it's on artistic works or scientific works and so on. For database rights, it's about on the database contents, of course. And for industrial property rights are on inventions or brands and so on. And what rights do they have? Okay, it's clear for scientific works. For instance, reproduction, sharing, and making derivative works is basically protected, and the rights holder has the rights on it. For database rights, replication, distribution, and using of basically substantial portions of the database is protected. However, for our purposes, once we want, for instance, a single dataset from a database, it's just enough that we refer to the terms of use of the database and see and read it and see if we can use that in a way that we want or not. And for patents, it's basically mostly related to commercial benefits of the protected. So let's focus on copyright. For a work to be protected by copyright, it should satisfy these two criteria. First of all, it should be, so basically there are individuality and originality. You might have heard about these two. What does individuality mean? So the work must be a personal creation or derived from personal choices of its maker. So a human must have made that work to be able to be protected by copyright. And originality means that it should show a certain degree of creativity. So a routine work cannot pass this, let's say this degree of originality and basically cannot be protected by copyright. So how can we use this in our daily work in research? Let's look at these three examples. So we have seen many AI-generated contexts, for instance, an image or a graph which is produced by DALL-E or some piece of code that is generated by ChatGPT. So it doesn't fulfill the individuality because a machine has done that, an LLM has done that, not human. So basically, it's not protected by copyright, and it can be original or not. It's a topic of discussion. I don't want to enter that. So let's look at the next one, raw data from scientific instruments. So an instrument is not a human, so basically it doesn't satisfy the individuality. And of course, it's not original because if you give the same input to that instrument, it's supposed to at least give the same results to you. So basically, it's not, none of these conditions are satisfied, so it's not copyright protected. How about the computer programs? So it's written by human, so it has some effort of human creation mind in that. It can be original, can sometimes be not original. So if it is original, then it is protected by copyright. So let's look at this concept, joint copyright or co-authorship. In legal context, if multiple individuals have created a work and they cannot individually exploit their contributions, then they're both or they're all co-authors of that work. Just imagine that a dialogue in a short movie between two people. A person cannot say that I'm the only copyright holder because if the other person is not there, then the copyright is not basically, then the work is not basically finished or it's incomplete. So when you want to use that piece of work for our purpose, the consent of each individual co-author is required to use that work. So we need permission from all the co-authors. If a paper has 20 co-authors, so let's not talk about the paper because it's published by a journal, but if a work has 20 co-authors and it's not licensed, we basically need 20 consents from individual co-authors that we're able to use that work. Let's get back to the research context. What is DPG's statement about this? A co-author is a person who has made a genuine and identifiable contribution to a research project, like developing the conceptual design of the project, software, data acquisition, and so on. But it's important to note that there is no honorary or supervisory or leadership co-authorship. So, as I said, if a work has several co-authors or even one author, then the consent of that author for the purpose that we want to use the work is necessary so that we are doing that legally. Let's see how it works for research. So first of all, copyright is granted automatically. As soon as the work is created, it's protected. There is no need to have this C sign on the protected work. So absence of it doesn't mean that it's not protected, and presence of it doesn't mean that it is protected. And the protection applies regardless of the publication of the work. As soon as you create the work, even on your laptop, it's protected. You don't need to publish it to make sure that it's protected or not. And it lasts for the author's life or the many authors' life plus 70 years. So it's a long-term protection. And under German law, it's not transferable. So for instance, if you make some graph and put it in a manuscript and then publish this manuscript via journal, you basically don't transfer the copyright to that journal. You transfer the exploitation rights to that journal. You hold the copyright forever, for the rest of your life plus 70 years. As I said, you need to have the consent of all the co-authors of a work to be able to use it. However, law has seen some exemptions that you can use a protected work without the consent of its authors or co-authors. And what are these exemptions? So copying or rephrasing the mere facts from a protected work in our own style, basically this is useful when you want to write your manuscript or your thesis and so on. You can basically rephrase the mere facts, not necessarily the you can copy the facts, not the ideas of the original author. You can quote directly from a work in quotations, of course. And you can also use the work which has been produced by government agencies. So there are some exemptions that you can use this. So if some data is published by a government, you can basically rely on that, and without really asking for permission, you can use that data in your work or that figures in your work. And making a copy of the work for personal use. So it happens a lot that I want to learn something and I see a figure. It's fine that I use that for my own personal study and learn something from that, as long as I don't publish it or as long as I don't use it in my own other works and so on. And this last point is interesting maybe for lecturers. Using up to 15% of the published work for non-commercial educational purposes is allowed. For this last point, I want to draw your attention again to the disclaimer that we had in the very beginning. However, the law here, which this copyright law number 60, is really easy to read. You can refer to it and read it and understand it yourself for your own purpose. So now I get to the licenses. As I said, if you want to use a copyright protected work, you need the consent of all the co-authors. And here is where licenses come to help us and help to streamline things. So what is a license, a copyright license? It's a permission granted by copyright holder, or let's say holders, to another party, which can be us, human, or journal, entity, or something else, to use the protected work in specific ways. And these licenses often define terms such as distribution of the work, reproduction of the work, modification of the work, and their commercial use. So in general, for research purposes, we can imagine two different types of licenses. One is for research data or outputs, and the most famous one in that sense is Creative Commons licenses. And for software and for code, you can imagine two different types of licenses, the copyleft licenses and the more permissive ones. That will go a bit into more details. So you have heard most probably about Creative Commons licenses. You have seen these signs in so many different places, also in the very beginning of this presentation. So there are 6 licenses, Creative Commons licenses, and two tools. So these tools are not licenses. Basically, if you see this copyright sign and being crossed, it means that the work has been identified as copyright free. So we are sure, or the person who has put this sign there was sure that the work is copyright free. So basically you can use, adapt, or share it. However, sometimes you see this 0, and basically this is called the CC0. Again, it's not a license, it's a tool. It means that the authors have dedicated this piece of work to the public domain. So you can use it, adapt it, and share it, and so on. And there are 6 sets of licenses, and these licenses are basically deciding if the work can be used for commercial purposes, if there are derivative works allowed, or if you build upon the work, what other licenses can you choose, or what licenses are you obliged to choose for that work, which is built upon the protected work. So just to be short here, share alike, SA stands for share alike. That means that you should choose a similar license for the derivative work. ND stands for no derivatives, means that you're not allowed to build upon the work. NC is for non-commercial use only, and there are also other combinations. So as I said, these two are tools, and there are 6 licenses. And if you're interested to know which ones satisfy the criteria for open access publishing, the CC0, CC BY, and CC BY SA satisfy the conditions. An important thing is that you should note that you shouldn't use, or actually you can use, but it's not really meaning something. You cannot use the Creative Commons licenses for software and code because they lack the necessary provisions. So what should we do for software? Which licenses can be assigned for it? So in general, there are 2 sets of licenses, copyleft licenses and permissive licenses. Copyleft licenses require that the derivative work stay copyleft as well. So if you choose, it's just enough now that you remember these 4 different licenses. If later you saw them, you can just Google and get more information. But copyleft licenses require that the derivative work also remains copyleft and remains free. And this free doesn't mean cost-free. It means that the source code is available for everyone to use, modify. And yeah, there are other licenses. Maybe the most important, the most famous one, or the most used one is the MIT license, which allows anyone to do anything with the code as they wish. Apache 2 also offers similar freedom. However, it also includes some IPR clauses provisions that allows the creator of the work to be more protected if there is a patent on some piece of the software and so on. Yes, and so now the question is, how should we choose an open source license for our code or our project? It depends, of course, on the project goals. And it depends on the level that we want to control the work. If you want it to be used later only, let's say, copyleft, or everyone has access to the source code, or it's open for everyone to be able to use it, then we decide for copyleft licenses. If not, we want it to be there, everyone can do anything, then we can just decide for more permissive ones like MIT or Apache 2. And also you should care that the license that you choose for your software should be compatible with the pieces of the code that you have used. For instance, if you're choosing, let's look at this example. Apache 2 patent clauses conflict with GPL version 2, but they are addressing GPL version 3. How can you know about these conflicts? First of all, you should check yourself the different terms of the license. For that, you should check the official websites of the license provider and exactly go to that license and check if this license is compatible with the ones that you're going to incorporate in your software. There's also a tool, Join Up Licensing Assistant. It's just enough that you search for this term in Google and you will arrive to this tool. You can insert your input and output license and basically see if they're compatible or not. And finally, for bigger software, it's really advisable to seek for professional legal advice. And finally, I get to the summary. So imagine that you see a piece of work, let's say a graph, in internet, and you want to know if you're allowed to use that work or not. So first, see if it is protected or not. If it's not protected, for instance, it's a piece of work from government agencies, you can use it. If the work is protected, check if there is a license or not. And if the license is there, see if the license is suitable for your purpose, if it allows you to do what you want to do with that piece of work. If it allows you to do that, then just use it. If there is no license or the license is not suitable, the best way is just to see if the work that you want to use or the purpose that you want to use the work applies or goes under these exemptions that I mentioned or not. If yes, then basically you can just use it. If not, it's imperative to contact the authors of the work, all of them, and ask for permission. Once you were granted the permission, document the permission, and then you can use the work. If none of this were a solution for you, then just don't use the work. Yeah, with this, I get to the end of my presentation. So last year, together with the team, I tried to spend some effort and collected set of legal aspects that we found relevant for researchers and summarize it in this document. You can access it in Zenodo or just scan this QR code. And yeah, thank you for your attention.